Hi, Assalamualaikum and good morning everyone. Today, our group will present on mechanical hazards. Our group consists of 6 people, namely Nur AZZRIN, Nur IZZWANI, Nur SYAFIQAH, KHAIRINA, Nur IMAN NUHA, and also NURFARIESHA DAHLIA. Mechanical hazards have been a source of concern since the Industrial Revolutions and the early days of mechanizations. Machines powered by steam, hydraulic, or electricity presented new hazards to the workplace. Mechanical hazards are still a serious problem today, despite advances in safety devices and approaches. Now let's move to what is a mechanical hazard. Mechanical hazards are those associated with power-driven machines, whether automated or manually operated. OSHA fined a company $190,000 for failing to provide proper machine guards and enforce their use. Now let's move on to the common machine injuries. In an industrial setting, people interact with machines that are designed to drill, cut, shear, punch, tip, staple, stitch, abrade, shape, stamp, and seal. This type of mechanical injuries that results are typically the results of cutting, tearing, shearing, crushing, breaking, straining, or puncturing. For injury hazards, the first is cutting and tearing. The human body's outer layer consists of the epidermis, dermis, capillaries, veins, and arteries. A cut occurs when a body part comes in contact with a sharp edge. The seriousness of cutting or tearing the skin depends on how much damage is done to the skin's veins, arteries, muscles, and even bones.
To understand what shearing is, think of a paper cutter. It shears the paper. Power-driven shears for severing paper, metal, plastic, elastomers, and composite materials are widely used in manufacturing. Injuries from crushing can be particularly debilitating, painful, and difficult to heal. They occur when a part of the body is caught between two hard surfaces that progressively move together, thereby crushing anything between them. Crushing hazards can be divided into 2 categories: squeeze point types and run-in points. Machine gears and belt pulleys are examples of run-in point hazards in Figure 2, 3, and 4.
Breaking. Machine used to deform engineering materials in a variety of ways can also cause broken bone. A break in a bone is known as a fracture. Straining and spraining. A strain results when muscles are overstretched or torn. A sprain is the result of torn ligament in a joint. Puncturing. Punching machines that have sharp tools can puncture a body part if safety precautions are not observed or if appropriate safeguards are not in place. Safeguarding. All the hazard can be reduced by the application of appropriate safeguard. Machine safeguarding is to minimize risk of accident of machine-operator contact. The contact can be an individual making the contact with the machine, usually the moving part, because of inattention caused by fatigue, distraction, and curiosity. The contact also can be from the machine via flying metal chips, chemical, and hot metal splashes. Also can be caused by the direct result of a machine malfunction, including mechanical and electrical failure.
Basic parts that
Next, OSHA requirement for machine guarding. First, type of guarding. One or more methods of machine guarding must be provided. Second, general requirement. Guard should be affixed to the machine. Third, guarding the point of operation. Any point of operation that might expose a person to injury must be guarded. Fourth, machine requiring point of operation guards, for example, guillotine cutters. Fifth, exposure of bladder. Fans must be guarded in any case. Sixth, anchoring fixed machinery.
Risk assessment in this context is the process of quantifying the level of risk associated with the operation of a given machine. It should be a structured and systematic process that answers the following 4 specific questions. The various machine motions present in modern industry involve mechanisms that rotate, reciprocate, or do both. This equipment includes tools, bits, chucks, plates, spokes, screws, gears, shafts, belts, and a variety of different types of stock. Safeguards can be devised to protect workers from harmful contact with such mechanisms while at the same time allowing work to progress at a productive rate. The NSC has established the following requirements for safeguards.
kind of operation guards are the most effective ways to prevent hazards from shearing, cutting or bending motion of machine. There are three types of guards: fixed guards, interlock guards, and adjustable guards. Fixed guards are permanent barrier between workers and the machinery, and it requires retail maintenance. Interlocked guards, it shuts down machines that does not securely in place and allows safe access during maintenance routine. And adjustable guards provide barrier against variety of different hazards. There are many point of operation devices. First, photoelectric devices. It shut down device when light field is broken. Next is radio frequency devices. It break the machine when there is capacitance interruption. Third, pullback devices. It pull operators' hands out of danger zone when machine starts operating. Fourth, safety trip devices. It include trip wires, trip pods, body bars, and it stops the machine when tripping happens. Lastly is gate. It provide barrier between danger zone and worker.
Assessment. The most effective way to keep the machine controlled properly is by running periodic self-assessment. This self-assessment can be conducted by security personnel, supervisors or employees. Therefore, developing self-evaluation criteria and encouraging supervisors and employees to use the questions provided on a daily basis is one of the good machine control strategies. First are all machines that might expose people to rotating parts, lead points, flying chips, sparks, flying particles or other similar hazards properly guarded. Second are all mechanical power transmission belts and the lead points they create properly guarded. Third are all exposed power shafts located less than 7 feet above the working level properly guarded. Next, feeding and ejection systems. Feeding and ejection systems can be effective safeguard if properly designed and used. There are 4 types of feeding and ejection system available for use with modern industrial machines. Firstly, automatic feed systems feed stock to the machine from rolls. Automatic feeds eliminate the need for operators to enter the danger zone. Such systems are limited in the types and variations of stock that they can feed. They also typically require an auxiliary barrier guard and frequent maintenance. Secondly, semi-automatic feed systems use a variety of approaches for feeding stock to the machine. Prominent among these are queues, movable dies, dying feeds, plungers, and sliding bolsters. They have the same advantage and limitations as automatic feed systems. Thirdly, automatic ejection systems eject the work pneumatically or mechanically. The advantage of either approach is that operators don't have to reach into the danger zone to retrieve wood pieces. However, these systems are restricted to use with relatively small stock. Potential hazards include long chips and noise. Fourthly, semi-automatic ejection systems eject the work using mechanisms that are activated by the operator. Consequently, the operator does not have to reach into the danger zone to retrieve wood pieces. These systems do require auxiliary barriers and can be used with a limited variety of stock.
Next, robot safeguards. The main hazards associated with robots are 1. Entrapment of a worker between a robot and a solid surface, and 2. Impact with a moving robot arm. 3. Impact with object ejected or dropped by the robots. The best guard against these hazards is to erect a physical barrier around the entire perimeter of a robot's work envelopes. This physical barrier should be able to withstand the force of the heaviest object that a robot could eject.
Control of hazardous energy. These are lockout or tagout language. First, affected employee, authorized employee, energized, capable of being locked out, energy isolating device, energy source, energy control procedure, energy control program, lockout, lockout device, tagout, and tagout device.
Provisions of the standard. OSHA standard for control of hazardous energy contains provisions in the following areas. We will be talking about energy control program and energy control procedure. For energy control program, Organizations must establish energy control programs that have fully documented energy control procedures, provide employee training, and ensure periodic inspections. For energy control procedure, organizations must develop, document, and use energy control procedures that contain at least the following elements. A. A statement on how the procedure will be used. B. Procedural steps used to shut down, isolate, block, and secure machines or equipment. C. Steps designating the safe placement, removal, and transfer of lockout or tagout devices and who has responsibility for them. And D. Specific requirements for testing machines or equipment to verify the effectiveness of energy control measures.
Next, evaluating lockout or tagout program. Firstly, are all machinery or equipment capable of movement required to be de-energized and blocked or locked up during cleaning, servicing, adjusting, or setting up operations? Secondly, is it required to lock out manpower disconnects instead of locking out control circuits? Third, does the lockout procedure require the stored energy, whether it is mechanical, hydraulic, or air to be released or blocked before the equipment is locking up for repairs? Fourth, are enough accident prevention signs, tag, and safety backlogs provided for any reasonably foreseeable repair emergency? Fifth, have employees been trained not to start machinery or equipment if it is lockout or tagout?
Here are some general precautions for handling machines. All operators should be trained in the safe operation and maintenance of their machines. All machine operators should be trained in the emergency procedures to take when accidents occur. All employees should know how to activate emergency shutdown controls. This means knowing where the controls are and how to activate them. And operators should be trained and supervised to ensure that they dress properly for the job. Long hair, loose clothing, neckties, rings, watches, necklaces, chains, and earrings can become caught in equipment and, in turn, pull the employee into the hazard zone. Basic program content. Machine safeguarding should be organized, systematic, and comprehensive. A company's safeguarding program should have at least the following elements. Here are a few selected examples of problems and corresponding actions.
The last part is taking corrective actions. What should be done when a mechanical hazard is observed? The only acceptable answer to this question is take immediate corrective actions. The specific action indicated will depend on what the problem is. Figure below shows selected examples of problems and corresponding corrective actions. These are only a few of the many different types of problems that require corresponding corrective actions. Regardless of the type of problem, the key to responding is immediacy. As shown in the examples given earlier in this chapter, waiting to take corrective actions can be fatal. It is important to note that it is often prudent to exceed some OSHA guarding requirements. That's all from our presentations. Thank you for listening.